Thanks everyone for joining us. My name is Rick Golba, and I am a product marketing manager here at PingCAP. You can see some information here on this main slide about PingCAP. We've been around for quite a number of years, and as of last count, we have around 550 employees around the world. And we're going to talk today about our hybrid transactional and analytical processing platform. Hybrid transactional and analytical processing is often referred to as HTAP. Tim Tadeo, who's going to be our presenter today, is probably one of the folks at PingCAP who is as passionate about HTAP as I am. So he is one of the solution architects. I'm going to turn it over to Tim. So take it away, Tim.
Okay, well, good morning, good afternoon, good evening, wherever you may be. So what we would like to do this morning here is, and I'm on the East Coast of the US, so this is noontime for me here. And I want to level set, first of all, and introduce HTAP. There has been, many definitions about it. It was coined by Gartner 5-6 years ago, at least. And one of the motivations for HTAP is the amount of information out there that businesses have, enterprises have, and they want to be able to operate and gain insights from that operational data almost immediately in some cases. So some of the approaches where you see how we gather business intelligence from these OLTP applications, it usually takes two platforms. One of the reasons it's hard to query and analyze, big data in real time is that it's hard to build these connections between the applications and then the various data warehouses or data marts that may exist in an organization. So when we talk about hybrid scenarios, we may think about companies having their OLTP systems, which may be enterprise resource planning systems. They could be retail systems, some type of e-commerce sites, and want to gain insights into that, CRM, those types. And then you have the different type of transactions being either OLTP, right, online transactional processing, or analytical type of queries that you run. So many times in the past, it has been due to the size of the volumes, the growing sizes of volumes, very hard to do that, as I said earlier. They almost have to split them into two different platforms, right? And then consume the data from these various sources, perform some type of extract, transformation, and load pipelines, right, to aggregate that data and put them in a different store. So there's a few problems that pop on the way, right? And as you know, and you've learned, between the two types of processing, OLTP that I just talked about and OLAP, there's two different, they're very different data processing methods, how you're going to process that data, because quite frankly, the requirements for those data platforms and the type of queries you're going to run are very different. So how people have done that in the past and continue to do it, as you'll see here, that's illustrated here, there'll be some type of application server that front ends an OLTP store and an OLAP store. And in those back-end processes, as those transactions take place into the OLTP part, it's going to pass through some type of ETL process, and then that's going to be stored on those, sometimes referred as offline data warehouses that you can see here. So it becomes, number one, complex to do that. You're using change data capture, you're doing those ETL processes, and the more steps, as is illustrated here, that you go through, you increase latency, right? And it becomes it really becomes a long path to get to that data. You have complexity in the design, and you're trying to serve like two masters here with an online application, as you can see here. Like I said, it could be an ERP, CRM, retail applications, whatever you have. And then you're also having the requirements to report against that data. So beyond even the complexities that we talk about here, it's a matter of time, right? How long does that take? Can I do this within 5 minutes, 10 minutes, 30 minutes? Usually not, right? These are usually processes that take place to gain insights into your operational data and have that freshness of data. It usually takes some period of time, and it is not that I've experienced in the last 10 years of doing this. It is not on a basis of 5 minutes, 10 minutes. It's usually half a day, and most times it's overnight type processing. So we're illustrating here, this is pretty much a common example, breaking it out into real components where you've got that siloed data, or using some type of change data capture, replication, or we're either streaming the data in, as you can see here, to satisfy these type of requirements. So again, the takeaway here, it's very complex to do this, and it's very difficult to do it. So what are some of these challenges that enterprises have here, right? Surging data volumes. There's never been a time as it is today in the amount of data that is generated through OLTP systems, right? And they have those OLAP requirements. The business's demand today that you always have an on store, a data store that's always on. You have to have the resiliency and redundancy, and the importance, another very important part with the surging amount of data volumes. You want to take advantage of gaining those insights into your businesses to take action almost immediately. And we're going to have a really good example of that today. And that's referred to as many times that I've seen as the freshness of the data, right? The data is only maybe a minute old, but that data could be, very valuable depending upon what you're trying to accomplish with that data, and to give that data value to that business almost immediately. Some of the options for OLTP, to get to that HTAP environment, there's, for example, sharding, and maybe I do read scaling off of that. And there's some complexities with that. Sharding is complex, and the schema is usually not very flexible in how you can change it, right? Because you're using an OLTP type of data model. You have application complexities that you see here. Some of the methodologies here to provide that HTAP and get that OLAP piece working is to have data warehouses. You can see here, data lakes, but they really are not real time, okay? Closest you can probably get to that is almost near real time. So as you can see, there's a lot of complexities, a lot of challenges. These are just some of the ways, as you can see, for the options that companies are trying to solve that. And they're older architectures. And then the other challenge is to use a single data model. So I've got this operational data store here. And yes, companies do, particularly like MySQL, Postgres, even your large commercial databases, yeah, they will run some known OLAP type queries against that data. But there are penalties, for doing that, right? You're usually going to increase some type of latency into your OLTP model, and it's really difficult to maintain that single, source of truth using those two different platforms, in OLTP and OLAP, right? So those are some challenges that are pretty common for enterprises trying to solve that HTAP, and it's not something that's easy to do. And why do they want to do that, right? What is the value in it? And here are some examples for credit card detection, gaming, IoT. You have a retail application system that wants to be able to do next best offer, next best action, and you could pretty much use your imagination where that real-time data coming from an operational data store, if I can do real-time analytics in what I can do. So there's a lot to be left to the imagination there on what you're trying to do. So that is what we're trying to solve here at TiDB with our HTAP solution. So I want to bring us through here to show us what that looks like, how we implement it, and I will make some references back to these earlier slides and how we really take a unique approach, and it really is a differentiator for a database vendor to be able to do this, because it is not easy to do. So off the top, some of the value things here, we are a cloud native distributed SQL database. I am going to go through these components here, what the architecture looks like. Okay, so moving from left to right, like any database, you have some type of protocol. We use the MySQL wire protocol for applications to access the TiDB cluster in general. So you have here, I'm going to take you through three components: TiDB, the PD, which is the placement driver, and then TiKV, which is a key value store where the actual data is stored. Let's talk about that first. So your applications come in, as I said, through the MySQL wire protocol into the TiDB. And that's a stateless layer. What do we mean by that? We mean we don't store any data there at all. This is where your connections take place, your parsing of your SQL, your optimization of your SQL, syntax checking, so on and so forth. And it also provides query throughput, right? Concurrency into the cluster in general. Going to the right, when we are accessing that data via select count from some table, we are using that underlying data store, and we call it a storage cluster, and the data is stored in a key value sense. So not to let any confusion, this does not make us a NoSQL database. We are fully ANSI compliant relational database and much more. So I'll go to the top there. We'll look at the PD cluster, the placement driver. And if we look at that, it really does a few simple things. It does what we call timestamp oracle. So when you do an insert, your records get a timestamp, and then the placement driver decides where to store it in that key value store. Okay, so you can think of, you're familiar with MySQL or Postgres. If you think about sharding, we do something called regions. Those are our shards. So PD figures where to put those on those regions, those shards, to keep a balance, right? Keep the data balanced. So that's how that works here. A fourth component, we won't get into it too deep. I do have a small demo on that, but simply to say, using something we call a Spark driver, it allows you to do massive processing of data using Spark, if you have Spark. And then you're able to both write data into the storage cluster as well as read from it. So it offers you a lot of value to do that. And there are implications here, what you can use that plugin for that is to your left. Now, what's important to understand how we do scaling, we can do massive scaling, is that we can scale all these components independently of each other. So I like to call it's loosely coupled, okay, to do that. They sit on their own instances, if you will, their own nodes, so we can scale that out. Okay, so really germane to our topics today, and we will show you scale out on all of those today, except for the TiSpark. So TiFlash is a column-based storage. It's column storage, columnar style storage here, and it's just simply an extension of where we store the data that you saw earlier on our storage clusters there on TiKV. And TiKV also is row-based as well. So those two are really help isolate the workloads. So we'll demonstrate today how, when you're doing your row-based OLTP, and then I start running OLAP type queries all on the same platform, there's workload isolation. One does not affect the other. So let's look at the scenarios here. This builds out that we showed earlier in the general type of use case, which enterprise is doing with an OLTP and OLAP to try to make the hybrid transactional analytic platform work for themselves. So we take, as I said, a very different approach here. So we really combine it, right, all in one solution. So as you saw earlier, we have our online transactions, our real-time dashboard and analytics, and that could be commercial type dashboards that you could use, Tableau or any open source or ClickView or Looker or any of those to access that data, retrieve that data, and so on and so forth. So just taking us a little bit further here, we look at this, applications come in through the TiDB server from both type of workloads, and we're really focusing here on the OLTP side of it and the OLAP side of it here. And what happens is those online transactions, right, your inserts, updates, deletes, even doing singleton point reads are really using that TiKV cluster where the row store is. And that data gets replicated not via change data capture, right? Because that's really outside of the database, if you think about it. So what we do is we use something called a raft protocol, okay? We're using raft replication to push that data to the read optimized TI flash column store for both scale, right? Low latency type of OLAP queries. Okay, and there's one other mention that I talked about before in there is using TiDB within our HTAP solution to further extend it. That's what I like to call it. Extend, give it some extensibility here, and using TiFlash, particularly with TiSpark, where I've got a Spark cluster. I have my TiSpark, which is an API just to plug in. Where I can run these Spark jobs to actually go after the TiFlash nodes, okay? And I can also write that data to TiKV nodes, which is the row store, as you see the cluster on the right, and then the data just gets replicated. So I've got a number of ways I can do that, and we're gonna show some of that today. So let's talk about what you will see here in the demo. All right. So in our real life demo application that I'm going to show you here, it's an electronics retail chain. Okay, but it could be retail for anything. So we're gonna use that as it makes a lot of sense. It's very easy to explain. Everybody goes shopping. Everybody buys something. It deals with some type of retail. So it's very easy to understand that. So in our scenario, there's a new sales campaign and we want to measure the performance of that, right? And what do we mean about it? Okay, is what we've put together for a campaign where we're targeting certain customer types that we want them to buy. We want them to pay a certain way. We're looking at maybe a region. And for me, I live in New England. It's 6 states. Right? It's Massachusetts, Rhode Island, Connecticut, New Hampshire, Vermont, and Maine. So maybe I'm targeting that area. And I also want to measure what products they've purchased, right? Is my again, we're trying to measure that sales campaign. Well, why are we trying to do that, right? We want to know the data, its freshness, because maybe I just want to look back every 10 minutes to see if my marketing campaign is successful. Or maybe I go back 30 minutes with this transactional data that's coming in where folks are browsing a catalog and then they're purchasing different items. Because I want to be able to adjust that. I want to do, as I say here, have actionable insights on that fresh data. Okay, so that is going to be the application will look like. And then I want to talk about some of the operational aspects, which gets into the ease of implementation, the ease of administration of this solution, this HTAP solution. So we're going to look at scaling out for query throughput. how we can scale out for query latency, both on read optimized and write optimized, where we're really going to focus in on TI Flash and talk about the OLAP. And I want you to come away with 3 takeaways if I explain this correctly and have shown it correctly, that you are able to have immediate insight into that operational data without the pain of doing ETL. And this is a clarification point. We are not trying to prove that we are an analytics warehouse. That's not the point here. We're not trying to replace the snowflakes of the world, but we want to show you how you can have real-time OLAP queries that are fairly large and run it against that operational store, which is really large as well. And the second point here is you can use an existing tooling set to be able to do this. I'm going to show Apache Zeppelin today because we are an open source company, and I thought I would just use it. And then, like I said, the simplicity of operations and how we reduce complexities and reduce those complexities and the ease of use as well. All right, so I am going to start off by showing you a few items. So what you will see here, and I have a workload running, I will come back to this. This would be the retail, the electronic store retail marketing campaign that we're trying to measure. And I will come back to this as well. So let me just move this down and we'll look at a couple things. So the first thing I do want to show here is, let's take a look at the data model. I'm going to bring this up here. It's important to understand this. Okay, so what we've created here is, it's a small data model. What I mean is number of tables, all right? And the main actors that are happening in here is customers are going in and looking at into the data here, looking at maybe would be a catalog, what have you. So we've got the 2 main operational tables that are doing the most work here. Is we have something called an order header, and that's simply what the customer ordered, who's the customer, when they bought it, so on and so forth. And that data is fairly large. Right now we're running, and I'm running a real workload against this now that we will increase and so on and so forth. So there's 434 million rows in here that go back over, oh God, I think the last 5 days. And then those orders, they get placed and then they get processed in this order details at 651 million rows. This is kind of what the model looks like: order number, line number, so on and so forth. These other tables are, as you would see in an OLTP, kind of static in nature. And I'll just put it as data so it's easy to see. What products they can buy, the product line, type of products. We have classified the different type of sales channel, how they purchased it. We have the customer type that we've classified, as you can see here. And then the customer table, which also has right now quite a bit of customers. We have 43 million customers. Okay, so I think everybody understands the data model. I can get rid of this. Now, I am running a real workload. So I'm just going to go to our dashboard just to show you that we are running a real workload. And this will increase. I'm going to add some more to it. So we're, roughly right now running, 18 to 20,000 OLTP transactions per minute. Okay. So let me now show you how we're running our workloads here. We'll start them up. Okay. So what I first want to show you, and this is just the TiDB client, okay, MySQL wire protocol client, and want to show you what we're running right now. So this is the OLTP transactions that are running in here now. And what's happening is orders are getting processed. Okay. we run an actual workload with real data that's going on. So right now I've got over 3,900 connections there. And how this actually runs here is we've got this workload running, call it production. And I'll just quickly look at this here. It's just a Python program that comes in. This kind of emulates this customer looking at a catalog and then purchasing that data. And we randomized either how they pay for it and then how they, what channel they go through. So we can put some real data out here. And then we have a second workload running that I call variable. And all it does is change those weights. It's a simple Python program that runs in here. So we're running right now through this Python client on this Python on this machine I have running here. We'll just look at it just to prove out my point here. Okay, rep this guy. Okay, so what we're running is 1,600 transactions, 1,600 workloads, okay, that are running right now. And they are all running 1,000. They're going to keep running for 100,000 transactions each. So that's how we derive that workload. Okay, now what I'm going to do here is we will go back to Zeppelin so we can explain our dashboard, what we're trying to do. Okay. So we're just using Apache Zeppelin here, and I've left the queries up here so you can see. So right now we're looking at the sum of payments and product types, what channel, sales channel over some period of time. So we're going back and we're going to run this every 5 minutes. Okay. So what'll happen here, this will keep running. And the reason we're doing this is, as I said earlier, explaining the demo, I want to understand this information to see, maybe I'm targeting people that I want them to buy our store MasterCard, right? So right now, my campaign doesn't look like that good yet, but we're going to maybe make some changes to that. And I'll show you how I'm going to do that as well. We want to look back in the last 10 minutes, the products purchased by customers through a customer type over a period of time, right? So they're buying through their commercial customers are on that program, their enterprise customers, as you can see here, and the different types of customers we have. And then we want to know, well, what are they buying the most? Because maybe we've targeted certain groups here to buy a certain product type, okay? Same thing goes down here. We're looking at a different metrics of the data here. Purchasing through the sales channels, the product type, and then the volume of what they are buying here. So we can easily look at it. Now, you can think of this as two ways. This could be an actual business analyst coming in here and looking at this because they're anxious, and then they could have also run ad hoc queries if they want to. Or this could be actually feeding, if we ran this kind of in a batch mode that wakes up every 5-10 minutes, just continually runs to then make some decisions, right, with that data that's consuming in real time, consuming a large amount of data, to maybe power an AI or something ML in the background that says, okay, I want to improve my sales campaign. So automatically the back-end application will say, start putting out next best offers to people that are on their phone and in my store or near a location, so I can affect that marketing campaign. Okay, so that's what we're doing here. Okay, and this has real business value, particularly in this case of trying to power that back-end applications to improve our business. So what I'm going to do here now is I have another workload here that we're running here called variable. Okay, and there's other here that are prod as well. I'll just make sure I've run the right ones here. Let's do a history. Okay, yep. So we're running my my production workload and variable workload. So now what I want to do is I'm only running 5 queries that you could see there. So now what I'm doing here is I'm running something called an HTAP workload. All it is some of the queries you just saw, but I'm going to ramp these up so I begin to run more concurrent queries here. Start putting a workload because I'm trying to show some scale, right? And prove out that really your transactional data, which is isolated, your transaction can keep going on without impact. So that's a real big value if I can do this real-time analytics here. So I've just created this thing called run BG HTAP. Okay, so let's do that. All right, so what this one is going to be a little bit different. I'm going to start 5 concurrent queries. They're going to execute 10 times. Yes, well, 10 groups of 5 that will continue to run. All right, so I'm going to ramp up the workload. So if we come back here and let's just look and see what we're doing here in the dashboard. So these won't go up by many. All right, the dashboard gets a little bit confusing. Remember, I'm only running 10 more concurrent or 5 jobs using, believe it's 2 concurrent queries running within those 10 jobs of 20. Okay. One place you can see this activity really taking place, I won't go too much into this dashboard, but just to show you that we are using the TI flash, right, massive parallel processing to process these queries. So this is to prove the workload is isolated, right? And it's getting the freshness of data. It is getting the most up-to-date data that's being inserted into our order details and order header, simply being replicated out into the column store side here. So if we take a look here, we're still running every 5 minutes. These will begin to change over time. So what I'm going to do now is I want to start another HTAP query here, another set of them. We're boosting up those workloads. And we will come back and look at the client. We'll see that 39, 34 number down here continue to change. Okay, so there's the queries I'm running here. All right, groups of queries within those jobs. If I just take a look here, we can see my HTAP query kind of batch mode, if you will, client mode are running. Again, it's just Python scripts we're using. So there they are. They're running. Okay. So now what I want to be able to do is I want to show you the ease of scale. How simple this is to do. So if we just come back and take a look, let's see here. Yeah, let's look at our cluster so we understand what's running. Okay. So here we have 2 TiDBs, which is the stateless layer, 2 TI flash, 3 TI flash nodes running. Okay, and then we have our row store running here. So this up here is our column store. This is our row store. Isolated workloads. So what I want to be able to do, I anticipate running more HTAP queries. So what I'm going to do here now is I'm going to scale out the cluster. And these are already built. The actual nodes are EC2 instances. Okay. I'm going to bring online another TI flash node. Okay. And I will show you what that looks like. All it is a very simple YAML file. So what I'm doing here is I'm bringing on a 4th TI flash node here. So I'm doing this real time, and this does not affect what is happening with my OLTP side of the house. So the reason I'm doing this is because now I want to scale up. I'm going to run maybe much larger queries, OLAP queries. This takes just a couple minutes. So it's very simple to do this. So if I take a look now, and I look at the cluster, okay, something happened there, 127. Let's just take a look at that. All right. take a look again. Okay, there it goes. It usually takes a few seconds or so. What happens here, remember those shards, those regions I talked about, those are getting replicated via the Raft group replication, okay? And that's happening and it's pushing those over there. Okay, so I've successfully scaled it. And then what I want to do is, okay, I am going to increase the numbers of HTAP queries I want to run. So I'm going to run those again. So I'm scaling out because I want to run more HTAP queries that are going on. So if I just quickly take a look over on my dashboard here, we can see now I've scaled up. Now, one thing to remember about this, these latencies look sometimes a little strange because HTAP queries, an OLAP query can run 1, 2, 3 minutes, or it can run 20 seconds. It depends on your requirement, right? So if I want to go back and measure 10 minutes, right? I just need the data to understand 10 minutes ago. It doesn't matter if the query, and on average, it's running in 4 seconds anyways, and this is bringing back millions of rows, trust me. It doesn't matter. It doesn't have to be millisecond. So when I do look at this TiDB dashboard, there's not a way for me to really break out what that latency looks like in a complete picture. I can do it from Grafana to show you the TiKV side. But yeah, it will skew what that number looks like. But the TiKV row-based is still really running in seconds or milliseconds, I should say, within that to some point. So that's how we scale those out here. And it's just as easy if need be here. We'll just take a look at, see how our queries are running. Oh, sorry, that was the wrong. I didn't want to do a scale out. I just want to access TiDB and take a look at our process list. Okay, so it's you can see the number of transactions have increased, and that is because we are running our HTAP queries. So at the same time as our workload increases, and I'm going to increase that workload from the transactional side of the house. All right. So let's just add, let's add some more of the variable workload. B. Okay, so I'm launching another 800 more transactions here. They're running concurrently. Let's take a look back here. Show the process list. Okay, so those, it'll take a little time for those to ramp up in any event. So the key takeaway here is I'm still able to, increase that workload. There it goes. Now it's starting to ramp up. All right. Maintain my latency, my consistency on that. And in a second or two, you will see this come up. All right. Usually takes a few minutes to ramp up. Okay. So couple other things I want to show you, and then we're going to conclude this for Q&A purposes. If I take a look, what I had showed you before, when I did my scale out, okay, for TiFlash, it is simple as this. I give it an address of that EC2 instance, right? Simple data directory, deployment directory, and a port number. That is as simple as it gets to run that. There's no additional software needed to be installed when I either scale this out or use TiFlash. Okay, there's no bolt-on component. This is one solution. And you should be able to contrast that in your mind, how that would look given those architecture diagrams saying how companies are doing it. If I wanted to scale out for write processing, which is the row-based, same thing. All of these look the same. If I wanted to scale out for concurrencies and throughput of queries, right? I scale out the stateless layer. Oh, wrong name. but just to show you. So I can scale out these independent of each other. It's all about knowing your workload. And then the final thing that I talked about, using TiFlash and TiSpark in our architecture. Let's make this a little bit smaller so I can get to my thing. I have an instance here of TiSpark running, interfacing with, in this case, just a standalone Spark. But this is just simulating is if I'm doing massive processing. And what I'm doing, instead of down here at the bottom, instead of just 10 minutes ago, well, because this is really massive amounts of data I'm bringing back, I want to go back an entire day. And again, maybe I've got a Spark application that's doing some other type of analytics, get some other insight into it. So I run that here. This will run against, really large amounts of data. And it's just the same query where I'm looking to see how people are paying. So this is actually TiSpark as a plugin, and this is actually going against the MySQL data, TiFlash data in MPP, and it runs, and it's going to keep running. This is all MapReduce that's running here, and it's taking longer because of the size of the data. I may have gotten an error there. I'm not sure. I'll have to look over here. But here's, looking at Spark, here's where these jobs are actually running. We can see them actually running in here. And this thing will keep running. These really are not really errors. It's a little bit different how this looks at. But I just want to show you that you can run with this. And we'll come back to this after it finishes. I think it's still running. I may have asked for too much data. Okay, so I want to be respectful of time. Okay, so we'll go to a question. The summary here is for our value. That's what it's about, right? Is to really empower those real-time HTAP scenarios. Want to improve that agility of the business. In this application here, it's a retail type of application where I can do next best offer, next best action, because I'm measuring my sales campaign that I put together, my marketing campaign. You want to be able to simplify that architecture to do this without having complex connections, complex replication, complex data pipelines, ETL pipelines. And at the end of the day, it's lowering your maintenance costs. So I know we're at 56 minutes here of the presentation demo, and I'll take questions if there are any.
Well, thanks, Tim. This is really good and very informative. It's amazing to see how you can do the scalability, particularly in real time like you just did. So thank you for that. We do have a few questions that came in on Slack. So the first one was, if I want to implement TiDB, what do I need to do to my app to make it work with the new database?
Yeah, certainly. So there's really, if you have an application, I'm going to assume somebody is maybe coming from another database, MySQL, right? We'll just use that. Well, you're just going to point using your MySQL client and just point it at TiDB. There's nothing you have to change on the OLTP or OLAP side to make that application work. You're simply going to bring in your schema, load your schema. I'm assuming this is some type of migration, or it could be a brand new application, and then just point it there. There's nothing in your application you have to do. Let's say if you want to do those OLAP queries that I demonstrated, there's nothing special you have to do in your application. And I'm thinking maybe the question relates to like sharding, because you have to actually in your applications tell your application where the data is on what shard and take care of those. So there's really nothing you have to change to use this. I'm just going to assume that was the basis of the question.
Cool, thanks. Another one is, how do my end users know whether they should be querying the row or the column data?
Oh, great point. Great point. And we covered that in a much deeper dive. So what we have is we refer to it as smart choice, right? Intelligent choice. So what happens at the optimizer layer, right? When we come into TiDB, and I'll just put that back up here very quickly and talk about that. So what happens is when you come into your stateless layer, the optimizer will look and understand right? The join you're doing, like if you're doing a join, number of rows you're bringing back, and it's going to understand, right, that it has two areas to go to get the data. Is that query better optimized to go to the row store or the column store, TiFlash? You do not have to have, as some of our competitors have, as a front-end proxy, where you actually have to give it a query pattern and put it in some type of proxy to know where to go. Okay, that choice is made for you, but you do have some options depending how you want to handle it. If there's some way you maybe want to handle it differently, you can force it to MPP and say, I don't care what the TiDB stateless layer is telling me after optimization. I want to force it over to TiFlash, right, using the column store. Okay. And the default is just have the stateless layer decide. And that's what I'm doing here today. I'm just having the stateless layer decide where to go.
Thanks. Certainly that sounds like an easier option, and
yes,
kind of prevents the users from doing something that may not be as optimal. Okay. There's one other question, and this is, can this TiDB handle really large data volumes like you'd see at a gaming company?
Absolutely. We actually have customer references where they are actually using TiFlash. We can get that story to you to handle that data. So we do have some customers actually doing what I was doing today. But IoT, I mean, gaming is one of our sweet spots. We have quite a few customers actually doing both on row-based and column-based powering their application.
Okay, any of you guys as attendees here, if you have any questions, you can just raise your hand. I'll just allow you to talk here if you have any questions.
And keep an eye out. We'll be doing future webinars, not in the too distant future, really going a little bit more a lot more deeper kind of into HTAP scenarios, using TiDB Spark, being able to feed back-end applications like Apache Flink. A lot of interesting stuff. We continue to develop our HTAP capabilities. So we're looking forward to hearing from you. Thank you for your time today.
Alrighty. Thanks, everyone. And like Tim said, we are starting a series of webinars, so stay tuned and we will keep you up to date. Thanks again for attending.